Good morning, class. We are now going to look at the ballistic pendulum. All right, so of course I have videos in here that I'm going to replace. That's cool. Right now, I am just going to download all of my assets here. Okay, and I'm going to give you guys a quick look into the calculator. We'll also look at I want to look at the video a little bit before I actually start to present the information on this. And sometimes I'm a little afraid. Well, you know what, I'll go and look here. Close these things here. Oh, I needed that thing. All right. So let me go to paper by 53. Okay, let me just delete this. And I'm going to call this impulse momentum theorem. All right, this is impulse momentum theorem. And this is what we're going to talk about. We're going to talk about Newton's second law. So we know that if we have an object here and we apply a force to this object, some net force here, of course, and let's just say that this is our x direction, we're going to produce an acceleration in the x direction. Okay, so we know that this is going to occur. We have Newton's first law: this object will remain at rest unless acted upon by an external force, or an object that is in motion in a straight line tends to remain in motion unless acted upon by an external force, thus producing an acceleration. All right, so and of course this will act back on, we have Newton's third law. It's going to act back on the thing that's pushing it. It could be your hand. So let's start there. So you've seen this before. This is just mass times acceleration. Okay. I would like to extend it. I would like to present it the way that Newton presented it. And that is the change in momentum over time. So this brings us to a place where I need to talk about momentum. What in the world is momentum? Momentum is this: P is equal to the mass of an object times the velocity of that object. So we could still break this down into components if we need to. It could be px, py, all of those things. So we have momentum here, mass times velocity. If I write our equation again, we're going to end up with delta p, and let's say that this is in the x direction, over t. So let's analyze this delta p. We're going to use the chain rule again. And we're going to say delta times m times v in the x direction. This is just going to equal to, let's hold v first, v, or the velocity, constant. And let's look at the change in mass. And then let's hold the mass constant and then look at the change in velocity. Okay. So now we've broken this down. This is going to, well, let's just continue on. Now let's look at delta p over t in the x direction. Now we have v sub x. Since v sub x is not changing in this particular case, t has no real effect on it. So it's going to be mass over time, change in mass over time. And then we can do the same thing here. Our mass is being held constant, and we have delta vx over time.